Hello everybody, and we're back for round two. So in the previous video, we got up to where we actually were going to talk about loss of insulation. We talked about category meter leads and appropriate meters for usage and systems and stuff like that. Now I'd like to get into what the loss of insulation is or what that means. So we'll talk about that for a moment. So what is a loss of insulation? Well, we know from basic electrical what insulation is, right? It's to essentially protect the circuit from leaking to any other metal conductors, right? So what we want to look at here is how does that happen? Because in a normal low voltage system, we use chassis grounds, we use engine grounds, things like that. Well, in high voltage, we can't do that because that could be quite dangerous if you touch any piece of those components and we've got really, really high voltage. That's going to hurt, right? Low voltage, no big deal, but we can't use that type of ground. We have to insulate everything on a high voltage system. And last class session that we were actually in person in, where we were talking about electrical and different types of grounds, we talked about floating grounds, right? So floating grounds mean that everything is insulated. We don't really use anything as a ground. There is a cable coming from battery positive and a cable coming from battery negative as well. Everything is insulated. So if any of that leaks out to the vehicle's chassis, engine, motor, generator, casing, anything that you could potentially touch and get hurt, that's a problem. So we have systems in place. I believe the last lecture that Mr. O'Connell did, he talked about isolation circuits and safety systems and all that good stuff on how they do that. So I'm not going to get into necessarily how that works, but I'm going to get into how to test it. So right off the bat, once there is an insulation or isolation fault, the computer picks it up, or the control module picks it up right then and there, and it will throw a code. It will not allow you to put the vehicle in ready mode. I can tell you that it's not going to kick you out of ready mode, and that has to do with standards. Even though it's sort of unsafe, they have to at least let you turn off the vehicle, and then they just won't let you turn it back on. I believe it's Ms.A standards, I can't remember what number, but they have to at least let you turn the vehicle off. It's not going to just shut the vehicle down on you once there's an insulation fault. But once you power down the vehicle, it will not let you repower the vehicle, and then it's going to give you a malfunction indicator light telling you something having to do with loss of insulation. Sometimes they'll tell you where it's at, sometimes they can't, depending on the type of system that it is. So I'm going to go through a couple of procedures on how to actually sort of system diagnose to make it easier if you don't know where the fault's at, and then we'll talk about how to perform the test once you found out where you need to do the test at. So loss of insulation means high voltage is leaking, right? Vehicle won't go in ready mode, and we'll talk about how to find out where it's at. So in the next slide, it says diagnose isolation fault by system, if you're following along. These next couple of slides have a bunch of writing on them, not a lot of pictures, but it's a step-by-step process. And really what we're looking at is we are going to turn everything off, and then we're going to engage the system, each system by system, in the high voltage circuit, and then we are going to turn each one on and see if a fault turns on. And once a fault turns on, we know, oh, that was our trigger system, right? Kind of like on a parasitic draw test, right? Where you hook your meter up, you see an excessive amperage draw, and you just pull fuses until the meter drops, right? Kind of same process, except instead of pulling fuses, we're going to be turning systems on and off. So follow through with me here. First thing you need to do is sort of reset everything, right? If the code's already in place, then we don't know when somebody's going to come in. So you are going to turn off all accessories. You need to make sure that the battery is at least 50 degrees Fahrenheit. If it's too cold, you may end up with a high voltage battery heater that will come on automatically and could trigger a fault when you don't necessarily want it to. So you want to make sure that the battery is at least warm enough for those of you who live in colder areas or work in colder areas. Down here in SoCal, it doesn't really become a problem. We do have cold days out here in the Inland Empire, so neither here nor there. Make sure your battery is up to temperature. Once your battery is up to temperature, make sure the engine is warm if it's a hybrid vehicle. We don't want the engine coming on unless we want it on or running. So we want to make sure that the engine is in closed loop and up to running temperature before this test has been performed if you can. Sometimes the fault tends to come on prior to, so it won't let you. If we can, we want to try to make sure that the engine's warm. You're also going to erase, after you've already recorded all the codes, you're going to erase all the codes having to do with isolation faults. That way we can start to pinpoint where it's coming from. So make sure you record all the codes, then go ahead and clear them. And then if we go to the next slide, we are going to turn the vehicle off. And then once everything's off, all accessories are off, everything is off, vehicle is powered down. We didn't remove any interlocks or service disconnects yet. We are just turning it off as if you're driving the vehicle and you got home and you turn it off. Plus all those other things we just talked about. Once you've done all that, where are we at? Step 4 says to repower the vehicle on. So all you're going to do, put on the brake, power vehicle on, and not do anything else. Each one of these steps are going to require 2 minutes because sometimes it takes a little while for that isolation fault to happen or for the code to pop on. So we want to give it at least 2 minutes so we know it's not that system that we're worried about. Just powering on the vehicle from the start allows us to identify if it is a DC to DC converter problem or a high voltage battery pack. And while we're actually here, let me just sort of reel it back for a second because I'm going to use some terms that we haven't really used yet. Normally I'd like to give you guys some vocabulary before this, but just in case we don't know, there's a couple of terms I'm going to use. The first one is going to be DC to DC converter because I just used it. DC to DC converter you can think of as your alternator. It doesn't work in the same way because it doesn't need to, but your DC to DC converter is generally going to step down high voltage to help power all of your low voltage electronics inside the vehicle, right? Anything that's 12 volts is going to be powered by your DC-DC converter, aka alternator, right? And it's getting its power from the power inverter. So what the heck is a power inverter? More terms. Well, we do know what a high voltage battery pack is, right? It's our battery, but much bigger and is high voltage. In our hybrid and electric vehicles, we all have a high voltage battery pack. Various voltage levels, but we know what that is. Well, we need to be able to control that, and we need to be able to take the voltage from my high voltage battery pack and divert it to our electric motor or maybe our AC compressor or whatever we want to use high voltage for. We have to have something that is going to essentially be a distributor, not in the same sense, it doesn't work like an ignition distributor, but it is something that is going to distribute where the high voltage is going to go to. Wherever the controller says it should, right? So if the controller is sort of monitoring everything and decides, oh, okay, the driver would like to move forward, we need to divert power from our battery pack to the electric motor. It's going to go to our power inverter. The power inverter is going to say, oh, okay, controller, divert power to motor generator, whatever it is that we're trying to power on. You want AC compressor, okay, we're going to go ahead and send high voltage that way. So that's our power inverter. The DC to DC converter is usually located right around or within that power inverter. So again, power inverters sort of help distributing if the DC to DC converter is inside of it. And I know there's a lot of terms. Just sort of bear with me, and if you have any questions, please make sure that you state them, so if anybody else has that question, I can help them out as well. Then we already know what motor and generator is, right? We have an electric motor. We have a generator that can either help charge a battery or use to drive the wheels. And then we all know what an AC compressor is for our air conditioning system. And in many of our hybrid vehicles and our electric vehicles, that air conditioning compressor is going to be part of the high voltage system quite commonly. So just some terms to talk about. So back to our step 4, right? We just powered on the vehicle. I'm waiting 2 minutes. All I did was power it on. No accessories, nothing on, just press my ignition button on with the foot on the brake, trying to ready up the vehicle, right? If I get a malfunction indicator light with an isolation fault during this time, it is either going to be from the DC to DC converter, because now the DC to DC converter is powering everything else. So that's one area that it could be. Or another thing that as soon as we power on is up and ready to go is our high voltage battery pack. So if I get a isolation fault in that first 2 minutes of turning the vehicle on, it is going to be one of those 2 components. And now I know I'm going to take my insulation meter and I'm going to go and test those 2 components. Step 5 says, okay, if I did not get a mil yet, the next thing to do is to test our generator. And so how you're going to do that is to force the engine running. So you can either do this with a scan tool, or you can do this in a lot of vehicles by just pedal to the metal. Put the gas pedal, not in drive, we're still in park here, put your gas pedal all the way down and it should force the engine on. Other vehicles like the Chevy Volt, you just need to pop the hood and it will automatically turn the engine on. A lot of times you can just use a bidirectional scan tool to be able to turn the engine on from mode 6 or something like that, right? So you can turn the engine on however you want, but you're going to force start the engine. If you turn the engine on, and again, it's a 2-minute deal, we're going to let that engine run for 2 minutes. What this does is it tests the generator, because that's the one that's generally going to generate from the engine running, which will then feed the battery pack, right? So if I have a fault in my generator, the engine running will cause that fault to turn on. And another thing that's connected to that is our power inverter. So when I turn the engine on, it spins our generator, and the generator wants to spit high voltage back to our high voltage battery pack. Something needs to control that, and that's our power inverter. So if there is a short in the power inverter, I'm sorry, not a short, isolation fault in the power inverter, we are going to get a code once the engine kicks on as well. So when we force the engine on, we are testing the power inverter and the generator portion. Now, a lot of times, sometimes that whole unit doesn't matter what's wrong. On the Ford Escape, it doesn't matter. All of it's one unit, and you're going to drop a couple of grand in a new unit. Doesn't even matter where it's at. But at this point, if you are able to repair those or send them out for repair, or they're not connected, so you can replace one or the other, that would be how you would isolate those. Step 6, so if I ran the engine for 2 minutes and no mil is still on, the next step would be to then take our, obviously foot on the brake, take our shifter and shift it either into drive or reverse, and you're going to sort of alternate that. Doesn't have to be at a particular speed, but throw it in drive. If you can, you're going to want to move the vehicle at least a little bit. You don't have to actually drive the vehicle, but just move it a couple of feet or foot or whatever. Go ahead and throw it in reverse and move it back. Throw it in drive, move it forward, throw it in reverse, move it back. We just want to get some movement happening, and we're going to want to do this for about, again, 2 minutes to try to give everything a chance to fault for us. So if during this time we get an isolation fault code while we're in drive or in reverse, well, now we've isolated it down to either the drive motor or the power inverter. So then now we know, okay, it's time to go test those components. Once you've gone down to step 7, so you've alternated drive and reverse, still no mil. Then what you're going to do is go to step 7. Step 7 is to isolate our AC compressor. Well, how do you think you turn on your AC compressor? You are going to turn on your air conditioning inside the cabin. So once you turn your air conditioning on, again, for about 2 minutes, we're searching for a mill. If we get a mill during this time, we know it's our high voltage AC compressor. If we do not get a mill at this time, then we know that it is our, then we know it's not our AC compressor. We have one last area. So we've done all of this and still no mill. There is one last thing that it could be. So what we're going to do is power down that vehicle yet again. Except this time we're going to wait for about 20 minutes while it's powered down. The reason for this is that there are 2 types of faults in your high voltage battery pack, or that we monitor in the high voltage battery pack. One is going to be an impedance fault, which is AC, the other is DC. So the DC happens a lot faster, or is checked a lot faster. The AC takes a lot longer to check, and it does it while the vehicle's powered down. So once you've gone through your warm-up cycle, you've done all these things, power down the vehicle in that 20 minutes, it's going to test for an AC isolation fault. After that 20 minutes, you power on the vehicle. If a fault pops right up, you know that it's actually going to be the AC fault having to do with the battery pack itself. And then again, sort of back to the beginning, we're going to have to test that battery pack. And when I say battery pack, if your high voltage controller is inside of the battery pack, it could also be a high voltage controller. So at that point in time, at least we've narrowed it down to the area of the battery pack, and now we can figure out whether it's going to be a battery pack or a high voltage controller. Some of these things we're going to get into in the diagnostic class next semester. We're just sort of skimming the basics so we know how to do an isolation fault and just sort of go through the basics. I'm not going to have you guys necessarily system test again. That may be an advanced class. I just wanted to sort of get into what that is, how you can go through that, because most of the time the code may not tell you where that isolation fault is. So lastly, it's how to actually perform the isolation or insulation test using a Fluke 1587. There are other meters that perform this test, but the ones we have at school are a Fluke 1587. So I'm just going to sort of explain it using that meter. In about 17 minutes, I'm going to go ahead and make that a third and last video.